Okay, so I think the one thing that people often forget, so how many people have heard of the You Broke the Internet initiative? Right, so the internet's completely broken and we should create a new one that's peer-to-peer and really nice and stuff. And I agree, that would be great. It would be great if we had a new internet which didn't have all of the legacy problems that we have with the internet and the web today. Unfortunately, we have millions, billions of people on the internet and web, and I don't know that many people on alternative systems right now, really. I mean, so Tor's huge, but you're still talking, 500,000, million sort of users, and we have many, many more people who use the ordinary internet. And I kind of feel like you have a sort of philosophy as a hacker. You can sort of say, I'm going to build something completely different, and me and my friends will use it, and maybe it'll take off. And that does work sometimes. That is actually how the web happened. And so it would be really cool if that happened. Or you could take another route and sort of say, we're going to look at the existing, effectively, mess we have today, and try to fix as much as we can. And so we're going to look at the latter path. And the fact of the matter is the internet and the web are actually, which is a bit of a miracle, they are open platforms insofar as that anyone, including random people over mailing lists, can effectively join a working group and contribute to the open standards that define the internet and web. And that's the sort of thing I like to remind people. The internet and web, it's not just software, it's not just hardware, it's actually defined on an abstract level of protocols. So some people, Morozov, for example, will sort of say, well, the internet doesn't really exist, you just have Facebook, you have all these different apps. Actually, there is effectively a fairly singular set of protocols that define these environments, right? So if something doesn't speak TCP/IP, it's not on the internet. If something's not speaking a version of HTTP in your eyes, it's not on the web. And people who don't understand that, to be honest, like Morozov, I think are idiots. We actually need to educate people about the importance of open standards. Because the fact of the matter is, part of the reason why we got in this mess today with pervasive surveillance is effectively the state of benign neglect that many people had as regards the architectural plumbing of the web and internet themselves. Very few people were taking active stewardship of these protocols and effectively leaving them to standards bodies which, to be honest, need your help. So that's why I'm giving this talk today, because we actually need more people who are really concerned about security, concerned about privacy, concerned about surveillance, concerned about freedom, to get involved into this process, because right now it's a lot of work and there's not enough people doing it. So, I just want to mention one thing. And also people say, well, things change really fast. But actually, to be frank, they don't. Most of the original concepts, in the web and the internet, they were around for the second known the internet had something like a blog. It was envisioned by Douglas Engelbart in the 50s as a way to solve large-scale global problems. We have lots of problems, and we need a trusted and secure internet to solve those problems. However, and what people forget also, which I think really has to be emphasized, is how many people here have participated in an internet engineering task force working group? Well, not a single one. Is it that bad? Really? So, okay, it is that bad. Not a single person has ever emailed the IETF. Okay, so often people say, well, I just went to this talk at Black Hat, and TLS is such a disaster. Why is TLS such a disaster? Why don't browsers do better certificate pinning? What is certificate pinning? How can we make sure that when I talk to one HTTP server endpoint and I'm a client, I actually verify that connection? And we're using good crypto, and we don't have all sorts of problems that have become very more widely known today. And actually, what you discover is that the core fundamentals of the internet, such as TLS, are effectively ran by groups of volunteers. Somewhat self-selecting, some people working there for companies, and they're running an open, consensus-based process, which is sort of crazy if you think about it. So it's a global consensus-based process, and that effectively anyone, particularly the IETF, can join. And this comes from the unique history of the internet, as essentially it was a research project, and basically graduate students got involved, and when they were defining the protocols for the software, because the military and the research units only paid for the hardware, they found what were called RFCs. Do people know what RFCs are? Do we have? Okay, so request for, okay, excellent, good, I was getting worried. Okay, so I'm glad people still actually read RFCs. So the fact of the matter is anyone, including you, could sit down and look at something, I know, for example, Tor's looking at this and say, I could create an informational RFC and suggest this. And then you can also say, I would create an informational RFC, and I actually think it should be a standard, and it goes through this process of widespread open review, eventually gets up to the Internet Architecture Board. This takes a few years. It gives a quite thorough review, and they either approve it or deny it. And the web, often people ask, what is the relationship between the World Wide Web Consortium and the Internet? Well, the web is an application that runs on top of the Internet. Right? So the Internet, of course, as everyone here probably knows, existed way before the web, and that the web may not last. We don't know. But the fact of the matter is, when the web started getting really big, a lot of large companies, large players started getting involved with the IETF, and the IETF is a much more loose and formal process. And so basically, Tim Berners-Lee, in order to sort of defend the open web from being taken over by a single company, I believe the problems at the time were Netscape and Microsoft, basically sort of said, hey, we're going to create a standards body, which is a consortium, which is more structured than the IETF, and which will handle just the web-facing layers. And that's the World Wide Web Consortium. Now, why a consortium? That sounds very exclusionary. Well, so the word open, everyone throws around all the time, open source, open standards. What does open mean? The W3C actually has a pretty good definition of open, which comes from the fact that it's a consortium. So even if you're making open source, you are possibly liable for licensing fees from software patents. And the US software patent system is completely broken and is exceptionally rife with crazy software patents. So effectively, by making a consortium of most of the large companies, we're currently running 300 some companies, including most of Silicon Valley, IBM, Google, et cetera, and then the newer ones like Facebook and Twitter, all of those patents are gathered together, and they make what is effectively a large patent war chest. And so if you say, hey, I'm a patent troll, and I have a patent on HTML, I have a patent on crypto and JavaScript, or what can happen is that W3C can sort of say, actually, we have a giant patent war chest of patent commits from major companies to HTML, and if you want to go up against us and IBM's lawyers and Google's lawyers, go for it, buddy. And that actually basically provides a large amount of safety for ordinary developers. So that's the important connection between open standards and open source. That while open source effectively deals on the level of the source code, we, with specifications, deal on the level of the software process. The more abstract level can be implemented in open source, can be implemented in proprietary code, and the consortium has its structure to defend against patents. However, the consortium is open for all sorts of participation. You usually have to email the working group chair and the invited expert, and they will basically give you status of what's called an invited expert. So I think a question is, with the World Web Consortium, is we basically start working groups. And how many people here participate in a W3C working group? Okay, one, excellent. Okay, so, well, it's better than the IETF, I don't know. So the W3C, basically, how we work and how we make standards is effectively mailing list, IRC, and depending on how your working group goes, telecons and bug tracking. A huge Bugzilla list. And so effectively, if you can participate in any of those mediums, and you can actually track the often quite heavy amount of conversation going on, it's very easy to get involved. And the W3C starts working groups in particular places which we view as crucial to the future of the web. So, for many years, there was this excitement around XML, a lot of work, of course, going on in graphics. And where the web has perhaps been weakest is, as everyone here, I would assume, is intimately familiar with, web security. And that's what we're trying to fix. So another difference is that the RFCs are all in ASCII, while the W3C uses HTML, because obviously the web may not be around. But one of the concerns we have in standards bodies is that as long as there's only a very small number of people sort of really involved in these sort of voluntary processes, and often people are paid by their employers to be involved, it's actually quite easy, or at least, let's say, plausible to manipulate the process. So we know that Project Bull Run had a segment of it was to actually influence standards bodies to produce standards which were more amenable to whatever the NSA's goals were. And this had a very large budget, $250 million. The W3C's whole operating budget is, I think, around $10 million. So it's actually very small, so they could have just bought us, I guess. But they didn't. And while we don't have any evidence that the W3C itself has been manipulated, there's been a lot of controversy going on in the IETF with one of the co-chairs of the International Cryptographic Research Forum. Well, he worked for the NSA, and this has, of course, been called out and discussed, and he's still the co-chair, but, it's by Trevor Perrin, among others. We do have a number of places where we have good evidence, not 100% solid, but solid enough that you should be suspicious that backdoors have possibly been put in at least the pseudo-random number generators recommended by NIST, and that NIST, the National Institute for Standards in the U.S., because it does have heavy cryptographic expertise, does often recommend the parameters, and we'll go into this with web crypto in a second, used by various algorithms. And this is becoming much more earlier because America was viewed as essentially having a sort of benign and neglectful role towards internet governance. And NIST, the problem with NIST has had sort of both an offensive and defensive sort of rules. So sometimes, you want good security standards internally, and you want enemies to have weak ones. And so therefore, people sort of had I would say, more trust in NIST than they had before, after the Snowden revelations. I think Snowden revelations did reveal that NSA was manipulating NIST in some circumstances, and now there's been recommendations from the White House, amongst others, to get that back in order. It's still a concern, and the question is, how do you detect that? Well, you detect that via open processes where you have lots of people involved, because the more people look at something, the more likely you are to discover the back door. If you're basically cooking up your standard, being in a closed industry consortium, no one will know if NIST or anyone else has manipulated your crypto. So what's been happening, which has been sort of interesting, is post Snowden revelations, there was a lot of outcry by the engineers. So most of these standards bodies are not ran by particularly, I would say, high-level types. The most participation comes from people who are implementers, or I would say at least engineers with a high interest implementation in various organizations. And most people were quite shocked when the Snowden revelations came out. Tim Berners-Lee, the director of the Web Consortium and inventor of the web, basically said that he felt that Snowden, is a hero, should be protected, and that there was generally a lot of internal reviews started happening, looking at what standards that we produce where they could have been influenced, and that the most important thing is that for all future standards, the Internet Engineering Task Force has basically decided that they should be pervasive surveillance, which is some sort of global passive adversary, which can basically monitor all ends of the communication network, should be taken as a serious consideration. So just as we have in most IETF standards security and privacy considerations, we should have considerations around pervasive surveillance. And if you're interested in this discussion, the IETF has a discussion at PairPass, which is a pervasive surveillance mailing list. And there's a lot of other discussion going on. But I'm going to give you more about what the W3C is doing, because that's who I work for. And the Internet Engineering Task Force has been very upfront, and W3C is still sort of working on our game plan for this area. So we did host a workshop in March, which you can look at if you want to know what we're thinking about. We write and make public all of our logs. And we were sort of saying, well, what can we as W3C do to basically help combat pervasive surveillance? And there's a lot of problems. So some of them are outside of our control. One of the larger problems, of course, is the problem of certificates, right? So, certificate management, certificates, basically, if there is not a hard fail for certificates. The certificate system has this ridiculous attack surface, which can be easily compromised. And a lot of that's out of our control. That's in the hands of private closed industrial consortiums like the Certificate Browser CA Forum. But at the same point, there are some things we thought for new standards which should be taken into account. So previously, in general, we have not taken into account data minimization principles. We have not taken into account ever traffic analysis. And of course, although the situation is pretty despairing right now around browser fingerprinting, we are trying to at least take these into account in future standards. And there are large amounts of problems, which I won't go through in detail, but effectively the web security model is well known to be broken. Very simple things like parsing URIs across various web browsers are not completely standardized and often prevent very interesting attack surfaces. So there's tons of stuff going on. I list quite a few of them there in all sorts of different working groups, but I'm going to concentrate on the ones that I'm working in. So the working group that I'm most involved with and helped start was the web cryptography working group. So we noticed the sort of disturbing phenomenon where effectively a lot of people wanted to do crypto in JavaScript. And they were really often very well-meaning people. And the fact of the matter is that it's in general, particularly a few years ago, a very bad idea. It's still often a bad idea, but we're getting a little bit better at it. At least we understand the problem and have some good things we can offer you, although not enough. So effectively, the issue is, even if I want to do any crypto in JavaScript, I basically have to call some server-side library. I have to often retrieve that library from another server. You basically have to trust whatever that code is. That code often has not been very well reviewed. So you look at openpgp.js, and well-meaning web developers. This came up with, I believe, CryptoCat, and has come up much more recently with ProtonMail, and it was even, strangely enough, mentioned by Ladar and Darkmail. There's this real desire to do things like provide end-to-end encryption in JavaScript, which is, at least without a browser plugin, a terrible idea. It just does not work because you cannot basically buffer the private key from the server. And furthermore, your cryptographic routines, they're not necessarily well verified. They're not constant time. There's all sorts of problems there. And so we basically don't want people to create, and I can't tell if it's advertising or just idiocy, something like ProtonMail, which basically claims to be an end-to-end encrypted email service, which actually isn't, because it just runs in the browser runtime, where you can't do that for very principled reasons. We would eventually like to get to the point where that is possible, but that's a long road. I'm going to walk through what progress we've made and what progress we haven't. So what we did is we did create a JavaScript web cryptography API. Just Google if you want to look at the API. And the API offers all the features that one would want out of effectively JavaScript web crypto. However, it is, so basically it's asynchronous, which is great. So it uses promises, which allows, so what you don't want when you're running JavaScript web crypto is you don't want to start generating a key and that jam up all the rest of your JavaScript code. It does offer probably too many cryptographic primitives. There's a bit of debate over this, but we do encryption, decryption, ECC, RSA, all of the classic stuff, all the hashes that you could, hash functions that you could possibly want, including ones that people don't like, and some of which are clearly broken, like SHA-1. But we do give all those to you, and we do want them to be sort of constant time. The problem is we do not, we realize that this API effectively is going to be used, we think, at least in this version, by people who are basically trying to code up some sort of protocol, and they can follow the instructions, and they understand their security models. What we're not trying to create in this version of the API is an API for end developers who don't know what they're doing, who just want some quick level of security. We would like to do that. The problem is that's very protocol specific, so we said we're going to create the most general purpose one we can in the beginning, and more higher level abstract ones could be created afterwards by essentially at first polyfilling and later building on top in a more cohesive way and maybe a second version of the spec. So that's called the high level API. But we have a number of open issues. So one of the open issues is, so how the W3C works is we create a draft spec. with the implementers involved, with a larger crowd involved. On the Web Crypto API, about, originally about 50 people in the room, and it's kind of died down a bit. But right now, we do have all the major browser vendors involved. And one thing that the developers want is the developers want Bernstein's ECC curve. So curve 25519 is considered, more trustworthy than the NIST-provided parameters for ECDSA. And this has been very controversial. It's actually still an open issue within the working group. Most of the browser vendors feel like providing this curve is a bad idea, mainly because it's unclear if that curve can be. So right now, DGB says, well, of course it's a great curve. But there's, of course, the Surgicom patent concerns. And also there's the fact that while DJB will provide in libsodium some very good code, the fact of the matter is, can you replicate that code across multiple environments? Is it well specified enough? And there isn't an IETF RFC for DJB's code yet. I mean, hopefully there will be shortly. And then if you're going to open up the door to different ECC curve parameters, why don't you open up the door to all sorts of possible curves? And if you do that, what else can you do? And this is where effectively Brian LaMacchia and other folks at Microsoft have been suggesting a new set of curves called the nothing up my sleeve curves. And these curves have been, and they already have them in Windows. They're available in the web next generation cryptography API from Microsoft. And should you expose those to the browser? So these are sort of issues that we have in a working group. What kind of algorithms with what parameters should we let into the API? And we have to balance that with the very real implementation concerns, right? So we don't have DJB's curve in NSS, which is the sort of baseline code which everyone uses for all of their crypto in their browsers, at least if you're cross-platform, such as Chrome and Mozilla. Other browsers, of course, call it, like Apple and Windows, call it underlying OS code. So that's one open issue. Another open issue is the sort of broken crypto issue. So we do give developers possibly enough crypto to shoot themselves in the foot with. Now, the reason why we do this is that we do believe that people will want some level of backwards compatibility when trying to do very well-known protocols, SSH, for example, using the Crypto API. And we do believe the Crypto API is not just going to be used in browsers, but will be a sort of standard API across all sorts of native JavaScript environments. So of course, we have SHA-1 in there, which is broken. We did remove PKCS 1.15 because we do not authenticate, force authentication. We do not force initialization, vector randomization. We do not, and we have a lot of algorithms there which of course don't have security proofs, and some of them, some of the password-based key derivation functions have known weaknesses. At the same point, if we feel that they are well specified and enough people want them, we are currently adding them in, and we're trying to figure out how to make it extensible. We do feel like crypto agility could be a good thing, and this is a discussion I'd like to have with people here, but we don't want to try to force people to use what we think is good crypto, and later we discover it's not. So we're trying to be non-judgmental, maybe one way to put it. Now, maybe the hardest problem, which we do not tackle, is key storage, right? So what a lot of people want to do is they want to basically do end-to-end encryption with some kind of long-term private key material. That private key material is hidden from the server. So we try to do the best we can. Currently, the best the Web Crypto API does is it basically does not pass around the raw key material. It passes around only handlers or identifiers the key material. And keys can be marked as either extractable, as in I can extract them from and get the raw key material and ship it around, or not. So we say, well, look, we can make keys which we say shouldn't be extracted, and we can also define an array of usages, such encrypt, decrypt. So you don't want to reuse keys for things, often destroys whatever security properties they have. And we often, and this is what we try to do, but there is some just fundamental problems with the web security model. So right now, we cannot guarantee that those key usages you gave for encryption and decryption and signing actually are attached to that key material forever. So it can be removed and changed by JS code, either from the server or from the user side. And we don't preserve those via inside of key wrapping and unwrapping operations. And furthermore, we only offer ephemeral keys. The keys are bound to the session. And some of that was on purpose. So there was a concern that effectively if we created another magical key storage mechanism without thinking it through very hard for long-term key materials, we would just be creating super cookies. And we don't really want more super cookies than we already have. We're trying, and this is very different from the encrypted media extensions, DRM, effectively, which is being pushed through HTML5, not my working group, and W3C, where we're basically saying the key materials should remain under user control. So the user should be able to delete keys whenever they want, and they shouldn't be forced to, there shouldn't be any key material which is hidden from them in particular. And so trying to figure out how you get key storage working in that paradigm ended up being a very hard problem. At the same point, there's a lot of good usages for having that, and we will return to those. And the last thing, which we notice is also